Hello students, good evening, and I hope you are all doing very well. You are welcome to today's lesson on diversity of living things, and we are on the part 5 or lesson 5 of this particular topic. In our previous lesson, we began discussing the kingdom Animalia. Today we shall proceed and then continue with this same kingdom. Let us now look at the objectives for today's lesson. And so by the end of today's lesson, you should be able to, number 1, state the main features of the 3 classes under phylum Platyhelminthes. And then 2, you should be able to state the main classes under phylum Nematoda and then give their main features or their main characteristics. So these are the lesson objectives for today's lesson. So you can recall from our previous lesson that the phylum Platyhelminthes has 3 main classes, and the classes we spoke of: class Tabellaria, class Trematode. Deeper into all these 3 classes. The very first I'm going to look at is the class Tabellaria. Now in this class, their features include they have no proglottids. They have no proglottids. When I say proglottids, they are the segments in the strobila of tapeworm that contains a complete sexually matured reproductive system. So that is the proglottid, which these organisms they lack. They don't have proglottid. Let's note it. Of course, they are also aquatic. They are aquatic, meaning that they live in water. They live in water habitat. Let's note it. And of course, they have a gut system, or they have digestive system, or they have a gut system. Let's take note of that one. Then next is that their body is covered with cilia. So they have cilia. They have cilia covering their body. So we should take note of that one. Then they also have simple eyes. They also have simple eyes. A typical example is the planoria or the planoria. That's one of the typical examples of organisms in the class Tabellaria. So let's take note of this one. So in your short now are some images of organisms in the class Tabellaria. So you have the planaria here. That's what you have in your short here. This is a very nice image showing an example of organism in the class Tabellaria. Let us now discuss the next class under the phylum Platyhelminthes. And this one we call it the class Trematoda. I normally call the flukes. So let's note this one. Now organisms here may include schistosoma, which causes schistosomiasis. We have Fasciola hepatica, that's the liver flukes. Let's note this ones. Members of the particular class are all parasites. They are parasites. They are either ectoparasites or they are endoparasites. So let's take note of that one. Then of course they live in the host blood. That is where you can find them. They live in the host blood because they are parasites. They invade hosts, so they live in the host blood. That's for the endoparasite. Note that one. Now, let's look at the main characteristics of organisms in the particular class. Their body is covered with thick cuticle. So they have a cuticle, a body covering that is cuticle that is very thick that covers their body. Let's note it. Then they also lack cilia. They don't have cilia. They don't also have eyes. So let's take note of that one. And of course, they have sacs for attachment to the host. So when they are on a host, they have sacs that enables them to firmly grip onto their host. Then they also have a gut, that they have a digestive system. This means they are also able to digest their food themselves. So let's take note of that one. Then lastly, they do not have proglottids. They don't have proglottids. In our subsequent slide, we shall be looking at what actually is the proglottid and what function does it play, or what role does it play. In your short here, we have a trematoda here, a trematode, that is the sheep liver fluke. There is an image showing the fluke, so take critical note of this image. And so the very last class I'm going to discuss under the phylum Platyhelminthes is the class Cystoda, the cystodes, the class Cystoda. We usually call them parasitic thick worms. So they are parasitic thick worms. Let's take note of that one. Now their main features include they have a very thick cuticle. So as their name suggests, parasitic thick worms. Parasitic thick worms. So no, they are parasites, of course, and they are thick worms. They have thick cuticle. Their body covering is having a very thick wall of cuticle that surrounds or that covers their body. Then they are also triploblastic. They are triploblastic. It means that they have 3 body layers. They have 3 body layers. So we say they are triploblastic. Triploblastic. Let's note it. And of course, they have suckers and hooks on their head. Their head. We call their head scolex. We call it scolex. So note that one. So they have suckers and hooks on their head, and this enables them to hold firmly onto their substratum or their substrate. Let's note it. Then of course they also have a long flattened body. Their body is very long and flattened, which is divided into segments. So these ones, they have proglottids. They have proglottids. When I say proglottids, they are talking about the segments that they have. So they have a long flattened body which is divided into proglottids. Let's take note of this one. Now they also have no gut. They have no digestive system. They have no digestive system. So take note of that one. This tells you that for the organisms under this particular class, Cystoda, example is the tapeworm. Because they don't have a gut system or they don't have a digestive system, they depend on the digested food that we take. So normally they are found in the intestines, the small intestines, where the digested foods are found. Normally they feed on these particular ones, of course. So let's take note of this one. Examples: if you have the Taenia cilium, that's the tapeworm. The tapeworm. Let's take note of that one, the tapeworm. So here in your shot you have a cystode, and this is typically a tapeworm. This is a tapeworm. You see how long it is and how flat it's looking. This is a tapeworm. Let's take critical note of this. So in your shots, see how long they look. That's a tapeworm for you. Let's now look at another phylum in the kingdom Animalia, as the phylum Nematoda. Phylum Nematoda. We normally call them the roundworms. The roundworms. The roundworms. Let's look at their main characteristics or their main features. Now they have unsegmented body. It means that their body is not segmented. They don't have segments in their body, so their body is not what? It's not segmented. Let's take note of this one. Now they are also bilaterally symmetrical, so they exhibit bilateral symmetry. This means that their body can be divided along only one plane to get 2 halves or 2 equal halves, which are of mirror images of each other. Let's take note of this one. And of course, they have both mouth and anus. So they have mouth, they also have what? Anus. So let's take note of this one. They have mouth and then they have anus as well. Let's note it. Then their body tapers at both ends. Their body tapes or tapers at both ends. So both the anterior and posterior ends, their body tapers at both ends. So let's take note of that one. Then of course, they have a cylindrical body. Their body is cylindrical in shape, a cylindrical body. So let's take note of this one. And then of course, some of them are free living. They are free living, means that they live on their own. They are not attached to any substratum, or they are not attached to any other organism or any other substrate. So they are free living. And then of course, some too are parasitic, which means that they live either in or on other organisms called the host and derive nourishment and things that causes harm to them. So let's take note of the feature or the main features of organisms in this particular phylum Nematoda, which we normally call the roundworm. Examples of nematodes, we can talk about the Ascaris lumbricoides. The Ascaris lumbricoides. This is a typical example of a roundworm, Ascaris lumbricoides. Let's note it. Then we also have another one, Ancylostoma. That's another one, Ancylostoma, and that's the hookworm. That's the hookworm. Let's note it. And we have Dracunculus medinensis. Dracunculus medinensis. This is what we call the guinea worm, which causes the guinea worm infection, as the Dracunculus medinensis. And you have the Onchocerca volvulus. The Onchocerca volvulus. That's another one. Of course, we normally call it the filarial worm. The filarial worm, Onchocerca volvulus. So let's take note of these examples of organisms in the phylum Nematoda. Let us now look at another phylum under the kingdom Animalia. There is phylum Annelida. Phylum Annelida. Normally call them segmented worms. Call them segmented because their body is segmented. So let's note this one. Now let's look at their main features or their main characteristics. And these organisms here, they show metameric segmentation. They show metameric segmentation. That is dividing or division into similar discrete units or similar units. So all the units are similar in terms of size, or in terms of shape. Let's note it. So division into similar discrete units, what we call metamerism. So they show metameric segmentation. The segments are of similar units or similar sizes. So let's take note of that one. Then also they exhibit bilateral symmetry. They show bilateral symmetry, which means that a body can be divided along only one plane to get two equal halves, which are of mirror images. So let's note this one. And of course, they also possess both mouth and then anus. So they have mouth and they also have anus. Let's take note of that one. Then of course, they possess the kiti or the chiti on each segment for locomotion. So you are saying that their body is segmented. It shows metameric segmentation. And of course, on each of these segments, there is a structure called the kiti or the chiti that they use for movement or for locomotion. And of course, they also undergo excretion. They also excrete, and their main excretory system is called the nephridia. Nephridia. That is their main excretory system. Singularly, we call it nephridium. Nephridium. So these help them to eliminate metabolic waste material from their body. So let's note this. Now we have to note that nephridia is also used for osmoregulation. Used for osmoregulation. Now this means that nephridia also serves the function of regulating their body water content. So the nephridia also serves the function of regulating their body water content. So we call it osmoregulation. So let's take note of these features of the organisms in the phylum Annelida, the segmented worms. Now there are three main classes under this phylum Annelida. So there are three main classes we can discuss under the phylum Annelida. Now these ones are, we have the class Polychaeta. We have class Oligochaetae, and we have class Hirudini. So these are some classes, or the three main classes we can talk about under the phylum Annelida. So let's take note of this one. In our subsequent slides, we shall look deeper into these three classes. So we shall now look at the very first class under the phylum Annelida. Now we are going to look at the class Polychaeta. That's one of the classes under the phylum Annelida. Now, organisms here, we can have the ragworm, the lagworm, the sabella. These are some organisms that we can find under this particular class in the phylum Annelida. Now, they are mostly marine organisms. They are found in marine water habitats. Specifically, they are found around the seashore. If you want to see them, you see them around the seashore. So let's take note of that one. Let's look at the main features of organisms in this class. Now they have a distinct head. It means that they have a head that distinguishes itself from the main body. So they have a distinct head. You can clearly see they have a head. So let's take note of that one. And of course, they have a parapodia which bears kiti. So they have parapodia that bears kiti. So let's note it. Parapodia is just a lateral extension on its body. As we go on further, we shall look at what actually is the parapodia. So they have parapodia which bears kiti. Let's note it. And of course, they are also well segmented. They have a well segmented body. So their body is well segmented. Alright, so you can see the segments much more clearly in this particular organism. So let's note it. And of course, they have separate sexes. They are not hermaphroditic, so they have separate sexes. So you see male and female separately, so they have separate sexes. So let's take note of this particular class. So here we have some examples of polychaetes. I see that some polychaetes here. That's bigger examples of ragworms. So these are ragworms. So take a critical look at them. As we discussed, you can see the features they are having. Now let's look at the second class under this particular phylum, that is class Oligochaeta. We usually call them the earthworms. They are the class Oligochaeta. Let's take note of this one. Now they are mostly terrestrial, and then some are also freshwater organisms. So you can find some of them in terrestrial habitats such as moist soil, of course in shady places as well. Then some of them too are freshwater organisms. So you can find them in these particular two places. Let's take note of this. Let's look at their main characteristics or their main features. Organisms in this particular class, they possess or they have a thick cuticle. They have a thick body layer covering their body, so they have a very thick cuticle. If you have seen an earthworm before, they can attest to the fact that it has a very thick body layer, a very thick cuticle that surrounds its body. And of course, it possesses what we call clitellum. That is a swollen or a glandular area that is found near the head of the earthworm, and it is also not segmented, so that's what we call the clitellum. As we go on, we look at the importance of the clitellum. Let's note this. Now they also have chytid on each segment, but they do not have parapodia. They do not have parapodia. They have no lateral extensions on their body called parapodia. So let's take note of this one. If you look at an earthworm, you will attest to the fact that it has no lateral extensions or no parapodia. Let's take note of this one. Then they also have no distinct head. Their head is not easily distinguished from their body. You can't easily identify their head on their body. So we say they have no distinct head, of course. Now, they are hermaphrodites, but then they undergo cross-fertilization. Organisms in this particular class are hermaphrodite, they are hermaphroditic, but then they undergo cross-fertilization. Now, this means that even though they are hermaphrodites, they have both sexes, or they have both sexual organs on their body, they are not able to fertilize their own eggs. Let's note it. So after copulation, so they copulate, they have sexual intercourse. So after copulation, they exchange sperms. And this sperm that they have exchanged goes to fertilize their own eggs. So let's note it. So we say, even though they are hermaphroditic, they undergo cross-fertilization. So let's take note of this one. So here in our short, we have an earthworm, an example of an organism in the class Oligochaeta. This is an earthworm. You can see this one is common. You've seen them a lot around. So this is an earthworm in the class Oligochaeta. So earlier we spoke of a clitellum, and we said that it is a glandular area that is unsegmented and is found close to the head of the earthworm. Realize that when you look at an earthworm, you realize that there is a swollen area. That is an area that is swollen. It is also unsegmented. It looks much more swollen and much more bigger, and that is what we call the clitellum. That is the clitellum of the earthworm. Now, it is used for attachment during exchange of sperms. So during copulation, where the two earthworm exchange sperms, the clitellum is used for firm attachment, so that it can be able to hold on firmly onto the other during their exchange of sperms. And of course, also the clitellum is used to secrete slime, also secrete cocoon in which their eggs are being stored. So after their eggs are being released, they are being stored in what we call cocoon, and the clitellum helps to secrete that cocoon so as to store their eggs in. So let's take note of this one. Now, the main function of the chytid in earthworms is for firm gripping or firm holding onto substratum or substrate or the ground during movement. So as it is moving, or as it is on a substrate or a substratum, it uses the chytid to firmly hold onto the substratum or a substrate, or what we call the ground, of course. So let's take note of this one as well. And so the very last class I'm going to discuss under this phylum is the class Hirudini. We normally call them the leeches. They are mostly both freshwater and of course terrestrial organisms. So you can find them in both terrestrial habitat and of course freshwater habitats. So let's note this one. Let's look at their main characteristics or their main features. Now they have clitellum. They possess clitellum. You know what the clitellum does already. So they also possess clitellum. They also possess saccs. The saccs are used to hold firmly onto substrates, onto surfaces. Let's note it. And of course, they lack parapodia. They do not have parapodia. So they lack the lateral extensions on their body. So let's take note of this one. And of course, they are also hermaphrodites. They exhibit hermaphroditic characteristics. You know what hermaphrodites are? They possess both the male sex organ and the female sex organ. So let's take note of this one as well. In your short now is a leech, and this is an organism in the class Hirudini. So we discussed earlier this typical example of an organism in the class Hirudini. This is a leech, as you can see in your shorts. And now we have to note these two key things. We spoke of parapodia earlier, spoke of chytid earlier. So let's look at what they really are. So when we say parapodia, now they are a paired or segmented lateral projections. So paired segmented lateral projection. When I say lateral, on the sides. There are some projections on the sides of the body of these organisms. We call them the parapodia. So they are paired, segmented lateral projections found on the body of the organisms we talked about in our previous slides. Now we take the Chaetae. Now the Chaetae are hair-like structures on the parapodia. So if you look at the parapodia, it has hair-like structures that we call the Chaetae. So let's take note of that. I believe we spoke of their functions as well, what the parapodia does, and of course what the Chaetae also does. In your short here, you can see the parapodia nicely indicated. So we have the organism there. You can see the lateral extensions, the extensions on the sides of the organism. That's the parapodia. So let's take note of the structure. So all too soon we have come to the end of today's lesson. For today, you shall have no assignments because you have a quiz tomorrow. And I wish you all the best for your quiz tomorrow. You have to learn on all the areas you have done so far for the quiz tomorrow. So let's take note of this one. I wish you all the best in tomorrow's quiz. Have a good evening.